Okay, so today we're going to do one sample t-interval for means, kind of like we did for the last lesson, but we're going to use data. So this is just going to be slightly different than what we did before. Let me just start with a new document here. Okay. And we will use lesson spreadsheets in a minute. Okay, so it says catching goldfish for school. Carly and Mason plan to be preschool teachers after they graduate. To prepare for snack time, they want to know the mean number of goldfish crackers in a bag of original flavored goldfish, because who doesn't want to know that? To estimate this value, they randomly select 12 bags and counted the number of crackers in each bag. Here are the data. Construct and interpret a 95% confidence interval for the true mean number of crackers in a bag of original flavored goldfish. So let's talk about the parameter that we would have first. So you would start with the true mean, and then you just write this down. I'm going to just say it though. The true mean number of goldfish in a bag of original flavored goldfish. That's the parameter we're studying. Confidence level is 95%, it says. What is the name of the inference method? So name the method. This is called a one sample t interval. Not a bad idea to also include the word for means. If you don't include that, it'll probably still be full credit for that. The calculator calls it a t-interval. So you might get away with that, but one sample t-interval for means is perfect. Random sample, I usually like to underline what it is in there and then put a note and write the word random sample on your paper. So let's see, 12 bags is less than 10% of all the bags that were produced by the company. What is the large sample condition? So there's three ways to prove this. So one way is to know the shape of the population. We don't know that. Another way is if n is bigger than 30, well, n is only 12, so that's not the case. So the other way, we actually have to draw the data. So then you would actually draw out, I think 335 is about the biggest here. 330. It just takes a minute to do this. 320, 315. I think that might be okay. Okay, I'm just trying to put, kind of X's where those points are. So there's 317. You can put dots too as well. 325, somewhere on there. 323, 332, 337, 324, right around, it's hard to put it there, but 342, ooh, a little bit more, so 342 somewhere on there. We have more out here, 349, 330, I don't know if I hit that one again, 335, right about there, 333. Something like that, roughly, is what it's going to look like. You want to make sure to label the axis, in this case, number of goldfish. So you could also say something like the words large sample or large sample condition or something. You could also say this proves normality or something like that. That would be nice. Degrees of freedom, 12 minus 1 is 11. T critical value, so if you remember doing that, you have to kind of like 95%, so 2.5 is to the left of that and to the right of that. So if you go to like a calculator scratch pad here, so we can go to menu 6, I think it's under 5, and there it is. Inverse t is the command you want, so 0.975 is to the left of that t value there. The degrees of freedom was 11, we said, and so it tells you 2.2. So t critical value is 2.2. Probably a good idea to put both the t critical value and the degrees of freedom on your paper. A lot of students forget to put those two, I would say. And now we need to know the stats of this. Well, we were only given the data, right? So we have that data up there. So what I would do is go back to like a list and spreadsheet page. I'm going to call it gold or goldfish or something. Type in the data. easy to get confused. So sometimes I make sure I have at least the right number of data pieces. I have 12 pieces, that's good. By the way, you could, if you go to a data statistics page, click, gold, it'll actually graph it for you, but then you would need to transfer that to your paper. It looks slightly different just because of the, if I grab, you can see it now, it looks pretty similar to what mine looks like if you grab it a little bit, but it will do that for you. Okay, so we want to do the test, right? So I'm going to add a calculator page, not a scratch pad, but a calculator page. Hit the home key and go to calculator and go to menu. I think it says in your paper 662. So menu 6 confidence intervals. And then this is called, again, a T interval here. And this time, unlike before, we want to use data this time, not stats. We have the data. So you have to have the name of the list, which in this case is gold. Defaults to 95%. Frequent list is definitely 1. And so it gives you all this information, right? So now we could probably plug into this formula because we know what X bar is. It's 331.4 plus or minus. T critical value was 2.2 times a fraction, I think. That was standard deviation up top. I like the way if you do it this way, it just tells you the standard deviation right there. SX is sample standard deviation. We took a sample, so that's why we're using that one. Divided by n, which was 12, or was it square root of n? Square root of n, right? Yeah, square root of n. Okay. So then you could type that in your calculator, but I prefer just to go 331.4 plus or minus the margin of error, because this guy together is the margin of error. It's good for you to remember. So that's 5.57. It just kind of helps remind you that, oh yeah, that's the margin of error. Now go ahead and write your lower bound and upper bound. So I'm getting this all from the calculator here, 325.8 and 330. I'm just going to round it to 337. 336.99 is rounds to that. Okay, so we have we've done all the steps of the do. The conclusion. And hopefully this is getting easy for you. I am 95% confident the interval from 325.8 to 337 contains the true mean number of goldfish in an original flavored bag. And you got it. That's basically it. As far as your lesson goes, let me see what I got here. So just this is more review. Everything we talked about with margin of error still applies to means, just like it did to proportions. So, if you have a larger sample size, the margin of error is going to get smaller. So it can be better. That actually is wrong there. It should say 1 over square root of n. I thought I changed that. So 1 over square root of n, quadrupling the sample size will be 1 over 4, square root of 4. So it's really 1/2 of the size. So it's 1 over square root of n right there. So not 1 over n. Margin of error. It'd be higher for larger confidence intervals. You need a bigger net to catch those. And then the margin of error doesn't have anything to do with bias. It doesn't account for that at all. Okay, that's your lesson for today. That was quick.